University, go Golden Hogs, and Masters in Statistics and Biostatistics from Western University, Boo Mustangs, and is frantically trying to finish his PhD in statistics at Western before the funding completely runs out.
Thank you for that. This is not showing his work.
What's happening?
All right, that's better. In the last presentation there, I noticed a plot that looks very similar to the ones that I did. One of the early ones is a plot from Micah on his dataviz.com, or hockeyviz.com. And I realized this work's mostly already been done, and that's not a good thing for me. But I've got some new things, so hopefully I can justify my work at least a little bit and not be wasting your time right now. Like you said, I'm stats nerd first. I wanted to apply models that I know. I'm working with forest fire data. What I'm actually looking at is locations of forest fires. Forest fires start generally in certain regions, but the location of the ignition is the random process. And then I was looking at some web-scraped hockey data. This is just from that weird API that NHL.com has. I don't know who runs it or where it came from, but what's that?
Major League Baseball runs.
Major League what?
Major League Baseball runs.
They run the API for NHL.com?
Yes. Yes.
I had no idea. All right. Okay. Okay, well, that solves that issue then. But I noticed the coordinates, and that caught my eye. I was just playing with this data anyway, seeing what visualizations I could do. I saw the coordinates, I thought, that's kind of the work I'm doing. So I downloaded that. Web scraped it. It took a long time just to get the data in. That was a fun process, but got it in, and I can plot it like this. And for anyone who was at the workshop yesterday, this is ggplot. This is R. All of this work's going to be done in R. I'm an evangelist for R because it's just a great system. And so this is shots for Detroit and Tampa Bay. And just looking at the raw point data doesn't tell us a whole lot. You can kind of see maybe that doesn't work. Okay. Maybe there's a couple extra shots over here, a few are over here. Tampa Bay's got more shots by the points. Inside the slot, it just looks like a mess of points, so this isn't telling us a whole lot more. So I'm using a hex bin to try and see maybe a little bit more patterns. We saw the posters in that session. I think Liam had a poster that was similar to this, where it's bin data. This is just the number of points in a certain location. And you can see where it's red, there's more points. Where it's blue, there's fewer points. That's going to be consistent throughout this presentation. Bonus points if you can figure out what colors these are. And white somewhere in between. This still, you can't see the pattern as well as I'd like, so this is a kernel density estimate. It's the same principle, just instead of hexagons of a certain size, they're infinitely small, and they take in information from the hexagons around them. And this gives us a little bit more information. So we can see the same patterns we saw before. More shots by the points to the right of the goalie, fewer at the point of the left of the goalie. Tampa Bay's got quite a few more. We can also see to the left of the goalie, there's quite a few more shots by Detroit than Tampa Bay. But that's hard to see with the rest of the colors. Really, it's just that one. The slot's just a giant red blob, and then you've got some white areas outside and blue areas. It's hard to really tell. So what I wanted to do with this is use the models that I'm working with anyway and apply it to hockey data and just see what insights I can get. So I'm fitting a model from point process methodology. That's the parametric model. And I want to know where different teams are shooting from, and are these patterns consistent? And I think this is what's going to set my work apart from Micah's. I get a measure of variance, which is something that is very important and you can only get with these sorts of models. I'm not looking at which shots go in. That's very difficult to do with point process data. We'll see why in a little bit. But really it's just saying what can a goalie expect and what can a coach tell their goalie to expect in a given game, and what would make that game different from other games. So the model I'm using is called log Gaussian Cox process, which we've already had a share of math today, so I'm going to try and keep this simple. The rate of a point in a given location is some intercept that I'm not too worried about. That's just changing the number of points in total, not in any specific location, plus a spatial covariate, and that's is one of the hardest parts of point processes, is finding a good covariate. Covariate has to exist everywhere on the ice, not just covariate like the goals at that given time. It has to be something that exists everywhere on the ice, plus this random process. And so if you're familiar with linear models, this looks pretty similar. You've got an intercept, y equals mx plus b plus some error. The difference with these sorts of models, first off, the rate of points is not something we notice, not something we observe itself. It is just that kernel density estimate. It's higher where there's more shots. We observe the shots themselves, not this rate. What that means for the so-called error term, this random process, is this process now, we have to put some structure on it. So random doesn't mean unstructured. There's going to be some very specific structure, and that's what we want. And I'm not going to go into too much detail about what it is, but it's based on a normal distribution. So this is some examples of what that random process might look like. On the left, we have low variance processes. On the right, it's high variance processes. And the only real difference is the left looks a little bit faded. The colors aren't as pronounced. The peaks and valleys on the right are much higher. The top versus the bottom is small clusters versus large clusters. So just maybe we would expect a lot of points from this location. And if it's larger clusters, we have a much larger area where there's a lot of points in that general area, but not as predictable of a point. So I mentioned the covariate. What I'm using is the league average. So this is just the non-parametric density estimate. This isn't based on any sort of model. This is just a smoother, like we saw before for Detroit and Tampa Bay. And I'm going to use this as a covariate. And so with that as a covariate, our interpretation becomes, we've got the log of the rate of shots, some intercept, which just modifies the number of shots overall, plus the league average, plus some sort of team-specific deviation. And now, whatever that deviation is what sets that team apart from the rest of the league. This is what makes everything different. So it can be seen as maybe, I put intended strategy difference. I think manifested strategy difference. This is what actually happens on the ice. The coach may have said, you should be shooting from the right of the goalie because I think this goalie is not as good on the right-hand side. But what actually happens is what we see in this random process. And the variance and range are the important part of this. It's what makes the team, is how you know these results are something that's true and not just some random variance, not just because there weren't a lot of short shots there, we just see some patterns by chance. The variance is my main thing I want to look at here. So estimation of log Gaussian-Cox processes is very difficult. It's something that people much smarter than me have worked on for much longer than I've been alive and are still just kind of figuring out, and they're still new processes, so I'm just leaving this. I'm not going to go into it. It's actually really interesting, and if anyone wants to talk to me about it later, go ahead. I'll gladly talk about it, but not everyone wants to hear that. So my results, this is the random process that I was talking about. And we still see Detroit. We said there was quite a few shots from the point, the left point here. But really, it's not that much different from what the rest of the league is doing. Whereas from that right point on the left-hand side of the goalie, there's not a lot of shots compared to the rest of the league. Whereas they've got this kind of arc of, there's a lot of shots coming from medium distance, not from the points, compared to the rest of the league. And I'm going to keep saying compared to the rest of the league because this is not, these are differences, they're not raw data. Tampa Bay, on the other hand, so I mentioned there was that they didn't have as many shots from the left of the goalie as Detroit did. It turns out Detroit's following the league with having a lot of shots from the very left of the goalie. Tampa Bay is just not taking a lot of shots from the goal lines in general. And then quite a few extra shots from the left point and from a little bit to the right of the goalie as well. The variance, as I said, I always want to look at the variance. This is, we can get the variance at every single point since we're doing this because of the way we estimated this. So I just want to call attention to a couple things. There's not a lot of extra variance where I said Detroit's not shooting from the right point. The variance doesn't show anything special going on there, so that's probably a pattern that we can trust. Whereas there's a lot of variance to the left of the goalie, and that's somewhere that there's also a lot of shots. So maybe that's just some random pattern. It just showed up because that's how points work. And Tampa Bay, we see a lot of variance by the goal line, but not a lot of shots there, so that's possibly the model's not fitting very well at that point. So I don't imagine that everyone here is either a fan of Detroit or Tampa Bay. So it's going to show up here. See how well this shows up. Perfect. As long as this plot shows. There we go. This is Detroit and Tampa Bay again. And I've got it so I can change the density. I can look at the random process. I can look at the variance again. Does anyone have any suggestions for teams? Oh, Ottawa, of course. Canadians? All right. So I'd like to start this off as the points because I'd like to point out again that just looking at the raw data doesn't tell us too much. Just looking at a smooth function of it doesn't tell us too much more. Both of these just have that classic pattern that we see in the league. Maybe a few deviations if you really look at it. So what we're really interested in is this random process. And Ottawa doesn't take shots. So the way I would interpret this, Ottawa is not taking many shots from the points or from the edges of the slot here.
That's just sad. Change the team. Change.
As opposed to Montreal. So Montreal, I want to talk about a little bit. I mentioned the cluster size. One of the big issues with this method of estimating these point processes is the cluster size has to be the same everywhere on the ice. So Montreal has a lot of points, a lot of shots from right in front of the goalie. And because that's a very small cluster, the cluster size gets estimated as a small value. And so there's small values of clusters everywhere, and that's why it looks kind of like confetti. And so interpretation of this becomes much more difficult, but doable if you have someone who knows what they're doing, aka hire me. And if we look at the variance, nothing special going on, except both of these teams do point out the variance is lower at where the league average is highest. So when there's a lot of shots in the league in general, this model knows what's going on, has no trouble fitting there. Variance is higher where there's fewer shots generally, but we see no special patterns, so these can be interpreted the same. One of the other little features is I've got this, I can make it so the colors are relative. And so now the scale of the reds is the same, so deep red on the left is the same as deep red on the right. And so we can actually see Ottawa has very low variance compared to the Montreal. If we look at the random process, turns out it's still no shots. Any other suggestions for teams?
Just change it.
Toronto, okay. Back to points. Toronto, and I'm going to show you Philadelphia for two reasons. So again, point process, just looking at the points doesn't tell us much. I'm going to jump right to the random process. Looks like Toronto takes a lot of shots from right in front of the net compared to the rest of the league. The rest of the colors are fairly muted. And so we're really mostly looking for very deep colors to see if there's a big difference. Muted colors are all somewhere around 0, so that's no difference from the team, but from the league. And so really Toronto just has that one peak right in front of the net, nothing else interesting. Philadelphia, and this is actually, I chose Philadelphia, one because it's the plot that was shown in the previous presentation that it was a difference from the league average, and I get the same results as Micah here. Philadelphia is shooting a lot from the blue line and not a lot from beside the goalie. And if we look at relative colors, oh, that was better. And so I mentioned, did anyone figure out what the red and blue were? Or can see it based on this now? They're Winnipeg's team colors. I made it so I can choose different ones. Let's do Minnesota. That looks horrible. That looks better. there's no point to this, I just... yeah, some of them turned out horribly. Also, every team is red and blue, or just red or just blue. You need better colors. So, just to finish off, again, all right, so a lot of these differences are minor, so you do see patterns, but it takes careful interpretation to know which differences are something that you should be worried about and which differences are just something close to the team, or close to the league. The cluster variable, or cluster parameter, can make interpretation very hard if you've got one small cluster, and this needs a lot of data. So if you have the league average and you have one shot on top of that, the model's just going to say, oh, they shoot a lot from where this one shot was. So you need quite a bit of data, so you can't just say, what about shots from this line during this game, because that's not going to be nearly enough points. You can't just look at necessarily goals for one team, because there aren't enough goals. So this is just general patterns, not anything in specific. But even with those limitations, I think this is a good method to see the way the strategy manifests itself on the ice. And with the variance, we can see if this manifestation is something we should look into. But it does need careful interpretation. And so moving on from this, I'd like to do some different play types, like that peak right in front of the goalie, right in the slot. A lot of that is probably rebound shots, and maybe I'm not too worried about rebound shots because that doesn't tell you anything about the strategy. I would just like the shot that led to a rebound. Also, a way to compare teams. Since this is on the log scale, it's a log Gaussian-Cox process. I can't just add and subtract things at random. I have to be much more careful about that. The spatially varying range parameter that's come up a couple times, and everything that you guys suggest, obviously. And acknowledge my supervisors, Doug Wolford, Charming Dean, and John Braun for helping me learn these methods. Some funding, just in case they come after me and say, why didn't you thank me? And if you have any further questions that don't get answered here, or you want to suggest things to me, that's my email. And thank you all for listening.
Pump your book. Thanks, Devan. Good job. One question about the data. So the way the data was recorded, of course, is just there's an individual deciding where the shot was just by tapping the screen. Now, 41 of your games are recorded by the same individual, and then 41 of your games is sort of by a big basket of various individuals. Did you do anything to sort of account for the fact that the data is coming, sort of somewhat being recorded in a somewhat biased fashion, unavoidably biased fashion?
Full disclosure, I didn't know that, so no. I wasn't actually sure how they recorded the location at all, whether it was from the player or where the puck was when it was shot, so that's interesting information for me.
So I have a question for you, and first I have an answer for Rob. This is going to come up in my talk again. I also did not correct any of my shot location data for rink bias, as it's called, because I found that implementing the rink bias adjustment formulas from Shuckers and more people, I'm sorry, I don't remember your co-authors' names. But I've discovered that rink bias is dramatically down over what it used to be in my data. That rink biases these days are on the order of 1 to 2 feet, even for the worst rinks in the worst spots. So the improvement there is considerable, and which is why I don't do it, and which is why I think you're off the hook. The second, but Robin's right, that is how it's done. They would get very nice blazers. The question I had for you is more technical, and forgive me if I missed it. Why did you use a logarithmic process, a logarithmic model, and not a linear model?
The logarithm in this model, if I can get back to it. So this is so that the random process is a Gaussian process, which will take positive and negative values, which we don't want negative shots in certain locations. The logarithm, so doing the exponent of the right-hand side is just to ensure positivity, and this is just the model that has been studied the most, essentially.
Okay.
Just computational reasons, basically.
So you're saying you're considering potential next steps. Have you thought about a way to sort of, I know, people were saying when you were selecting teams, they're like, oh, like Ottawa without Carleton, or like the first thing that I see when I saw the Philly thing, the first thing that I think of is like those, when they're, predominantly from the blue line, the first thing that makes me think of is like Wayne Simmons is parked in front of the net and they're trying to get him to dip it in and they missed. So have you considered trying to come up with a method to sort of like factor out or in individual players to see their impact on the team overall?
Yeah, one of the other ones was not specific players, but if I use same team but different lines throughout a season, I think shots from a specific line, as with the data, I know exactly who was shooting each thing, so I can look at which line shot what. I think the lines would be enough data, but I'd have to look into that a little bit more. Yeah.
I don't think you should exclude rebounds because it is part of the coaching strategy because it means the rest of your players have followed through on the play. So it actually means your strategy is stronger because of that. Maybe the application of the strategy wasn't success, but the full follow through was. But dividing it out would be neat to see how many of those in the close proximity are from rebounds. And maybe that helps add the rebound type of notion into a strategy.
Yeah, so when I said that, it's still something I'm thinking of. I was thinking of just studying the shots that led to rebounds, because that would be very interesting information, because the rebounds are important, and you want those rebounds. So if I looked at just shots that led to rebounds, that might be a new insight, yeah.
All right, we're good. Thank you very much.
Thank you.